Tanzu Tuesdays. Your host, Tiffany Jenigan.
I still feel so excited whenever I have like this intro. I've never had an intro for me before.
That's how you know you've made it. You're in the big time now.
So you're telling me to make fireworks with my mouse. What do fireworks sound like if you do that? I need
Well,
I need a demo.
you need the demo. It's pew 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 pew, right? Isn't that?
It's not really that's not really fireworks because fireworks do, like they have the explosion and everything.
All right. Boom 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 boom. I don't know. This is your job. It's your job to be ridiculous and make us laugh. And instead you're pushing it onto me.
Yes. Thank you for that wonderful demonstration, especially since I missed seeing fireworks this year. I don't know. I think I heard a few booms around, and that's kind of about it. Wondering if something's going to go catch on fire.
Yeah, we definitely had a lot of fireworks in our neighborhood, even though you're not allowed to. It still happens.
Yeah, there's a lot of stuff people aren't allowed to do, but happens anyway.
Right?
So yeah, if anyone has missed the last one, we are back in session and having talks every Tuesday. So I'll go through some of the upcoming things. So starting with Tanzu Tuesdays, which is what you're watching right now. There is on January 19th, so next week, there is Spring Native with Sebastian Deleuze. And that's also at the same time, so 1 p.m. Pacific time. Then tomorrow at noon, so all this is like at Pacific time, or most of it for now. But tomorrow at noon, Mario Gray is for code is going to be talking about and coding for initialization with Spring Cloud Data Flow. So code basically involves our Spring developer advocates talking about Spring related things and live coding. We also have between chair and keyboard. So basically this is a bunch of conversations. Nate Shuda has a different person each week and ends up having conversations with them about various topics. It's not like this one where it's a pre-planned thing of we're going to talk, there's someone is giving a talk on something. So on January 18th, Nate will be talking with Deshaun Carter. And then every day, Cote has an interview or discussion about something related to cloud native software. And that one is actually at 11 a.m. It's like Central European time. So not everything is stuck on us US time zones. And then we have TGIK, it streams on YouTube, but we also have a mirror of that runs as well. And that's on the next one's this Friday, January 15th. And Josh Rosso will be giving an update about the Carvel project. And as Paul phrased it, with some sweet demo and live coding action. So definitely check that one out. And that's at 1 also. To get to all these things, the easiest way is if you just go to tanzu.tv, and there's if you get really into it, there's like little shorthand, so like tanzu.tv/code or /TT for Tanzu Tuesdays, etc. And it basically will have all the upcoming, all the sections of different types of talks we have, and then you can dig through and see what's upcoming, and you can also see the videos for things that had happened in the past. And usually these come online within a couple days of when they were actually done. And then the only conference that I know of that is upcoming is DevNexus, and that's online. It's February 17th. You can just do devnexus.com, and our fellow advocates, Mark and Nate, will be speaking at that.
That's Mark Shooter and Nate Heckler, right?
I knew you're going to do something. They'll find it. They're next to each other. It's just on the thing.
Cool. And I think DevNexus is like a Java-focused conference. Is that right?
Yeah.
Yep. Cool. Nice.
I mean, it kind of makes sense with our Java experts being over there.
Right? Yeah. So I imagine we'll be spreading a bunch of Spring love across the Java ecosystem at that conference, which will be fun. What else have we got going on? Have we got a guest today? We do. Who's our guest today?
What? Who's that? Huh?
Sorry, you left the door unlocked. I snuck in.
Yeah, Tyler, why don't you say some words about yourself?
Sure. Words. Yeah. So I work for VMware with these two folks. I work
I'm
on
so
our
sorry.
what?
I'm so sorry.
Tyler actually has the misfortune of having worked with me in a previous job as well.
Right. I don't know if we count this the third time because it's an acquisition, or this is still number 2.
Wouldn't that make
Could
it
be pivotal also.
That would make it number 4. Oh, you didn't quite. You
No,
were
I was
post acquisition. Yeah, that's right. All
Yeah.
right, 3, nearly 4.
Almost, yeah. So yeah, so I've had the misfortune of working with Paul and knowing him for quite some time.
Even more sorry.
So I work on our developer engineering team in Tanzu. So our developer center, tanzu.vmware.com/developer. We have lots of good content on there, different posts and things like that. And more recently, in I guess like the fall timeframe, we added workshops. So there's hands-on workshops that you can just do whenever you want. I think we have like 6 or 7 up there now. And now in the new year, we're looking to add a lot more.
And Tyler, you were like the brains behind all of that integration work, right?
Well, some getting it into the portal. It is like most things in tech. It's there's a lot of duct tape and chicken wire and Django and Bash scripts and things like that. But to the outsider, it appears to be relatively streamlined.
It appears to be
nice.
integrated.
Yeah. I'll sometimes be like, "Hey, Brian, what do you think about this idea?" And then instead of making me do it, he's just like, "Oh, okay, here you go. Here's a PR for the thing you just mentioned." I'm like, "Oh,
Nice.
Yeah, luckily you weren't the only one who had that feedback too. You're like, yeah, this is when. Then even when I said I was looking for something, and I'm like, if I'm having trouble finding something on the site, other people will definitely have a problem finding something on the site. So it is nice though how regularly it can get. We get stuff updated. We're doing our good approach of Git ops and all that fun stuff, and so we had that's how we can get a bunch of different people being able to add content to the site all the time.
Yeah, and so for those that don't know, Tanzu.tv is actually hosted on the developer portal. So if you go to Tanzu.tv, you'll see some magic URL rewriting, and you end up on the developer portal in the TV section.
you stole my words."
And yeah, I stole your words, as I do. Yeah. Oh, also on there, I actually just finished updating the Getting Started guide for installing Harbor with Contour, Ingress, and Cert Manager for securing it. So if you're interested in doing that and getting a Docker registry with like secure endpoints that you can just point Kubernetes at without having to fight CA certificates, it's super useful. And I will be very soon updating it with a guide on then extending that to use it as a Docker Hub proxy to work around the Docker rate limits. Because if you've done anything with Docker in the last few months, it's pretty random if it's actually going to work, especially when you're dealing with popular images. And the Harbor proxying clears all that up for you. So keep your eyes peeled for that. And
I'll be adding a quick start or getting started guide with Valero this month too.
Oh, sweet. Yeah, this the stuff we're going to talk about today, I haven't written it yet, but will also be some content on there as well. So the actual, you'll see all the repos and everything are public right now, but an actual sort of step-by-step guide to replicate this.
So basically, we're your guinea pigs, is what you're saying.
Yeah, right. We're
gonna
do it live.
If this somehow works, we'll write it up. If it fails miserably, we'll just pretend it never happened.
Exactly.
Nice. Cool. Is there anything else we should cover, or should we just dive straight on into it?
I think we can just dive into it, unless you have any other random questions to ask.
Oh, I'm going to save them to interrupt him at inopportune times and try and make it as
that's my favorite time
for him as possible. All right, let's do it. Share your screen and let's go.
All right. Can you see that right?
Yes, sir.
Good deal. So, so what we're going to talk about is Knative.
See, I'm already going to interrupt you. because I'm going to say hi to little Bobby Brindley on the stream. I just see him in chat. So Bob, long time no see. I'm glad that even though you've left us, you're still here in spirit, or in this case, the chat room.
We do the rap air horn in your honor. So we're going to talk about Knative Eventing and how we can use it for sending Kubernetes events to an observability platform. So just real quick at a high level, Knative is it's an evolving set of tools. So there used to be 3 pieces to it. There was serving, eventing, and building. Building sort of went its own separate way because it didn't really fit in there all together. So that's what Kpack is now. Basically takes that spot there. And the Knative serving is handles the ability to deploy code and scale it out, sort of like you would with any sort of serverless platform. And then sort of basically that with eventing can give you, what you consider, a serverless type platform, where this event gets triggered, you can tell it to go run some instances to do some things. So there's a lot of examples that covers sort of those use cases out there. And what I wanted to do is focus on one that's just the eventing side. So I feel like a lot of demos for a lot of technologies will be like, deploy the whole thing, and then here's all the stuff you can do. And sometimes it can be overwhelming if you want to just try a smaller use case. So like, okay, deploy this, deploy Istio, deploy all these things, and then you can do all of it. Whereas if we want to just start small and say like, oh, let's just mess with eventing, kind of that's the approach I wanted to take a look at for this project I was working on. So really what eventing is, there's nothing message specific to code. So there's a standard cloud event format that passes through the various components, and then you can access it different ways. So you can have something that creates an event and puts it on a queue. You can have something that sends it directly. There's a lot of different ways. You can have different channels. You can have different triggers. It's super pluggable, super customizable on both ends, both the sources and destinations. So example sources, you could have something just as simple as a cron job. So something is scheduled, like fire these events, say on the hour, just fire an event. Things that trigger changes like GitHub. So say a pull request, a commit, a merge. You may want to kick off some other process, some other checks. You do that. Google Cloud Storage, AWS, SQS. There's a bunch of different event sources, and they're not incredibly hard to write either if you want to add more of them. But there's a lot of different ways you can create messages for the events. And what's nice is they're totally separate. So you see when we get into the actual code is you can just deploy an event source, deploy a broker and target and all those kind of things, and it just goes. You don't have to, they're not tightly coupled. So the most basic thing, which is sort of what we're going to do today, is we have an event source, which in this case is going to be Kubernetes events. And then the target, we're just doing in memory. So the broker is getting it, and based on the trigger, sending it directly to our receiver, our function. It can be just that simple. There's a lot of ways you can make it much more robust. One of the ways is using channels and subscriptions. So you can use different queues. You'd use things like SQS or Redis or something like that, where event is triggered, it's put on a channel, and then different subscribers can listen to that channel. It can be multiple channels, and they listen for specific events. So you could have one queue that handles a certain type of work, and then the individual consumers, sort of grab their own events and trigger it. So in this case, the end thing doing the work that's being triggered is a separate code. But within the scope of Knative Eventing, the subscription is on that channel. So to give you an idea what this looks like in our favorite Kubernetes YAML is you need a channel. So this is the one we're going to use too, is in memory channel. So we're basically just saying, hey, when this source happens, just send it directly. There's no redundancy. If a message gets lost, there's no resending it. It's just ephemeral. And this is the event source we're going to use too, is the Kubernetes event source. This is one of the ones that's pretty out of the box, which is we can get the events that happen on the Kubernetes cluster. So whether that's pods being deployed, deleted, all different things, but we're going to focus on one specific type of message, which we'll talk more about once we scale a little bit into it. And then same thing. So this is the source, and in this case, we're sending it to a channel, not directly. So you can see it's this eventing demo channel, and then the subscription on the other side can receive it. So you say which channel are you subscribing to, and which subscriber is receiving it, and it's just another Kubernetes service. Your event sources, they can be existing event sources that are in there, or you can specify contain. This is one of the easiest ways is you can build your own in a container image, and then you just specify it. It's pretty straightforward. So let's get rid of slides and get into the actual setup here. And what I'm going to use a kind cluster. So Kubernetes and Docker, if you haven't used it before, it's pretty great. And I'm leveraging this nice repo here, which is setting up Knative on kind. So let's sort of take a look at what this looks like here. Basically, you can run this and it'll go through and install all the components. So you can see the first one creates the kind cluster for Knative. Then the second one installs serving. And then we get further down, it'll deploy venting, and away we go. So the only reason I'm not going to use this whole thing is because I don't want serving, and I don't need eventing configured in the way it would if it would be paired with serving. So because I just want eventing, I'm going to deploy those separately. But I am going to use this first script right here to deploy my kind cluster. So we can kick that off. Okay, I actually have, let me actually show you. I have this in a bash script because the only thing better than curling to bash is to have a bash script that curls to bash. So as I mentioned here, I'm going to use that first one here to create the cluster. I'll just step through these individually.
I think it's actually okay now to curl to bash as long as you only do it to Kubernetes.
Let's see here. So you can see this is going through pretty normal kind stuff if you've never used it before, which scanning the images, right? Creating a Kubernetes cluster, and then it's going to make some extra configuration options. Then after that, we're going to install the Knative Eventing components. So you can see here, this is the Knative Eventing repo. That has all the stuff for it here, and we're still going to be deploying on 19.0, but it looks like they have already out to 20.0 is out. If we look at this here,
you don't want to live dangerously and upgrade.
right now,
because
I'm sure it won't work. 19 I know works. I mean, I'll definitely try it later and update it, but sometimes it can be with this ecosystem where it goes, okay, we went from .19 to .20, everything's broken, and we started over. And
or like, oh, hey, you're doing a demo?
All right, so it's waiting for the cluster. And then we'll finish deploying those components. You can see here, the first thing we're going to apply to this cluster is the CRDs. So those are the custom definitions for eventing that are needed. Then we're going to store the core components. And then as I showed in that example, we're going to use the in-memory channel. So that means we're just going to send it straight through. We're not going to put it on any channel. There's no redundancy if lost messages, no guaranteed delivery, anything like that. The same thing, it's going to the memory broker, which is just going to pass it straight through. Then the one thing, because what we're going to do here, you'll see metric server. What we're going to do is the Kubernetes event we're sort of caring about here is the horizontal pod autoscaler. So one of the things, okay, this is done. Let me just get this. We'll just apply these quick. One of the things that's useful. Oops, I need my calendar. One of the things that's useful is adding additional information to your monitoring or observability tools, where if you're capturing your application's, say, performance data, you're seeing transactions per second, the wait times, all those types of things. If you're deploying on Kubernetes, you may be using the horizontal pod autoscaler to allow that application to scale up and down as needed, which sometimes can make it harder to understand some of those performance metrics. If they're per individual, individual pod, individual request type things where it's taking X long. But if you're looking at any, say, total transactions per second, you're like, well, it just doubled. Well, do we have twice as many pods now? Maybe that's why it doubled, or did something else happen? So it can just give you a little bit more context around what's happening in your environment, right? So we have deploy. Let's deploy the in-memory channel.
So the in-memory channel, if you want something that's a bit more robust, is it Kafka behind the scenes or Rabbit? What's the?
You can use. There's a bunch of different ones you can use. Let me see if they list them right here. Here we go. Channels. So you can see there's Kafka, the in-memory one, GCP PubSub, NATS, if you want to do NATS. There's some external ones that use Rabbit and some other ones. It's, like I said, it's pretty pluggable, so you can sort of pop in there whatever you want. I think
Nice.
Kafka is the most popular in actual real-world use cases.
And then the in-memory one, because it loses messages, does that mean it's just Mongo?
Ooh. See, I've already put that one in. Yep. So now I'm just adding the metric service, and then I have this nice little patch here because metric service doesn't work right on kind on the current versions. So we have to adjust the pod spec slightly. So let's see. So let's change to our eventing namespace. Look at our pods. So what we have here is we have the eventing key event, the main eventing services, controller and the webhook, and then the broker, the in-memory channel there, and then the broker. So if we do, you can see now all the deployments for the different pieces for the broker, the channel. We should be just about good. Okay, just making sure. All right, so just make sure this controller is okay. Yep, all right, controller's happy. So cool. So we have our basic components there. We have eventing in there, we have the channel, we have the broker, we have no sources, and we have no destinations yet. So if we want to start there, that's the next thing we do here. So if we look at what we have in here, we have some roles and role bindings. So you can see we have a cluster role, event watcher, and we're going to bind that to the service account called events SA. So we're going to create a service account called events SA, and we're going to give it a cluster role of event watcher with this binding. Then our source, so you can see we're going to use an API server source. So this is the Kubernetes API server source. It's just called test events. We can call it whatever we want, but it's going to use that service account to access the API to create events. And then you'll see here the sync. So this is where does it go? To the broker. So we have a default broker for that for now. So this is it. There's not much.
And to just butt in, for anyone who hasn't heard of Kubernetes, basically it's an open source tool that Ahmet Altbalken created, and it lets you switch between namespaces. There's also a kubectx that lets you switch between contexts, and they're all pretty cool. You can just find them on GitHub.
Yeah, it's nice. It gives you this nice really switch. You can also, just using the dash, let you cut back and forth between your last two. So super handy. Between that and kubectx.
I probably use it 50 times a day, but like the two of them combined. So it's well and truly worth the price I paid for it.
Right, let's see. So we are, let's see. Okay, so now we want to apply the, and also the same, you can see I'm using ZSH. So it has a whole bunch of Kubernetes shortcuts. They're just K commands. So KF is kubectl apply -f for a file. So I can just KF a file. So you want to, so you can see we created a broker. We created this service account, cluster role binding. So all those from that file we just applied there. So then the next thing we need to do is get the get those events somewhere. So we need a consumer. So starting at the bottom, we have a trigger. So a trigger says, for this broker, send events to this URL. And you can see, if you're familiar with your kubedns, it's the service name, the namespace, and then service.cluster.local. And you can see this is the service right here to be sending it to. So you can see it's on port 80, the target port's 8080. And this service is pointing at this deployment for this image, which is this code over here, which we'll get into in a minute. And then this account, this service account here, you can see it's got a cluster role binding, service account, HPA sender, gives it these credentials, these capabilities. So it allows it to access the core API group. So those are the, when you see here, API versions in any kube manifest, right? So this says V1. This alone means it's one of the core ones. You can see this one's in apps. This one's eventing.knative.dev. So different, this is what groups you're giving them access to. So what this needs access to is the core APIs, and within that core API secrets. Also from the autoscaling group, it needs horizontal pod autoscalers. So we'll get into why it needs those in a minute. And it can get, watch, and list. That's it. So we give that service account. We apply it to this deployment of this software. So it's going to use, whenever it tries to make a call to Kubernetes, it's going to use those credentials. So we can just deploy this. Right, so it created the trigger, created the service, the deployment. So let's take a look at that. So there's our HPA sender right there. We can see that's all we got so far. Just listening on 8080, which, as we saw here, is being is from port 80 from the service. So if we sent it a message, that's where it would receive it on. So it's just sitting there waiting. Let's get it. Well, let's actually look into the code that's actually doing this. Like, what's running on here before we deploy an actual app that we can kind of try this out with. So if we look at the main code here, this here is, if you're not familiar with Go, Go is very strongly typed. So you have to be very explicit about explaining what a variable or data look like. So instead of an object, it's a struct. So what we have, this is our event data, which is like I said, there's a standard format called cloud events, which follow this format. So what we're doing is, this is where we're going to feed the data into. So when we get a call to our app, this is what it's going to look like. These are the fields it's going to have. So we want to define that. And then we're using the Cloud Events SDK as a Go SDK. So we're using the Cloud Events SDK to create a listener to listen for that. So right here, we create a new client, and then it listens. So this is that we'll listen on 8080 we saw there. So that means it's sitting there right now, waiting to receive events. And then it'll call the receiver down here once it receives a message. So if we look at what happens when a message actually arrives, it's going to put that data. It creates a variable data of matching that event data that we described up here. And then it's going to use this to put the data in there. So you can see attempts to populate our object with the event payload. So we say, take this event that's showing up and put it in this data. And if there's no error, continue. If there is an error, then display what the error was. And then what we're doing here is, you can see that here where the data source component. So if we go back up here again, we can see source right here, and component is what component from the API is providing it. So in this case, it's the horizontal pod autoscaler. So it's saying if it's that, mark that we received an event in the log, and then we're going to get into what we're going to do next with secrets and things like that. And then it's going to send the message off. So let's actually fire this up. So here's now the part where we have an application. So we have a pretty basic app. It is right here, it's a PHP Apache container on port 80. So it's just an Apache server with PHP. We're just going to run one of them. I have port 80 open. We're going to expose it as a service. And then we have a horizontal pod autoscaler, which is telling us we want at least a minimum replica of 1 and a max of 5. And then how we want to scale it by. We're saying we want to scale it by a target CPU utilization of 50%. So if it's over, it's going to scale the up to 5 to keep it under that. And if it goes over, it's going to scale them back down. So this is a very basic horizontal pod autoscaler configuration. The last thing here is you'll see the secret. So I mentioned there's some secrets in here. What we're doing is we're going to tell, so it's not specific to this one autoscaler. In the code, we're actually looking to see if there's a configuration for the autoscaler. So if we look at this app here again, you'll see this right here. This is something that the code's looking for. So if I get a horizontal pod autoscaler event, bring that one up and see if there's an annotation on it called HPA event. And if there is, go get this value, because this is the secret, the configuration for the autoscaler event is stored in. So default / PHP Apache HPE. So it's default namespace, and this is the name of the secret. So this is that secret right here. So what's in the secret? First, it's the URL. So where are we going to send this event? In our case, we're going to use Wavefront. You could use Honeycomb. You could use pretty much whatever tool you're using to monitor, New Relic, Datadog, whatever you're using to monitor your apps. That you would just have the URL there. Headers are a JSON, key value pairs of any headers you want to include. It just says token right there. I'll actually put a token in a little bit. And then this is the body of it. So if we go over here, you can see one that's different. So for Honeycomb, this is the API key headers they use, how they do their markers. And you'll see these underscore messages. Basically what I'm doing is using those as substitutions. So if I want to include the message from the actual autoscale event, wherever I put in my body underscore message underscore, it'll replace that with the body, and the same thing, time is just the current time. So if something requires, if your service requires a time, if if it doesn't, if say it was nothing, you could just put say nothing there. Same thing with wavefront. So I just set the start time and end time to 0. So let's go back here.
So the underscores were just denoting that it was like something that you're going to search and replace for with those numbers.
Yep. So it says if I see exactly this, then this is what I'm going to replace with. We'll take a look at the code in it.
Hopefully you never run into a case that has that whatever the word is as part of something else that you care about.
Yeah. This is super hacky, obviously. I could probably pick something a little bit more obscure to avoid that, but.
Yeah, I can see why you're doing that though, because if you were to use like dollar or dollar curly brace, then you might end up fighting like a Helm template or something else that's trying to transform variables.
And also one of the things which I'll show you, which I told Paul a little bit before we started, is I was fighting with a little bit is you can see the body's JSON, but if you look here, we have 2 different bodies, not surprisingly, but this one has, this one is all just key value, key value, key value, but this one is key value, key object with values, key array. So like we said, again, going back to Go, we said Go's very structured. So they're saying, hey, this is exactly what the data is going to look like. Makes it a little bit more difficult. If we knew exactly, like if we were coding this for one specific platform, we could probably do the replacing a lot easier because we can just say like, hey, we don't need to supply the message there. We can feed it in. And what we're actually doing is we're just dumping it all into a raw message because like it's JSON, but we don't know what's in it. And then we're modifying it, which I'll show you how we're doing that too. So if we have all this good to go, what I'm actually going to do is pause this for a second. Not that it's an important token, but all right, now I'm gonna deploy our app. Cool, so our secret's created. I put that in the right place. Yes, that's fine. Okay. All right, so get rid of that token. So, okay, so it's in there. So if we see what we got here. Oh, we're still in the eventing space. But if you can see now, we have a little bit more stuff here. So we have, here's our broker. Our broker has a URL and it's available. Our in-memory channel is up and running too. For the trigger, everything's ready to go. So if we switch back over to our default namespace. So here we have our pod. We only have, let's check our horizontal pod autoscalers. So you can see here, it's PHP Apache, targets unknown of 50%, minimum max 5. It'll take just a little bit because we literally just started it, 55 seconds ago, before this updates from the metric server, but this will change to a 0. So we can actually just watch it if we want. How should we do that over here? So just leave that there. Let's open another window. Let's watch our HPAs into there. So you can see we've already gotten a couple messages. And the messages are, unsurprisingly, failed to get CPU utilization. So it didn't get any pod yet. So those will clear out in a minute once we get some. Actually, there we go. So now it says 0. So if we do, so we have it's working now. But this is what it'll look like. So you can see what happened was it says, hey, we got a message. We got an HPA event. And then we went and found that HPA and we saw that it had a secret. So we got the data from the secret, we sent the message. I think that may have actually already created an event. Yeah. So this is something we probably want to filter out, but it created a bunch of events for failed to get rid of a. So let's clear these out. So if we go back here, so right now we have just one. We have, let's do, we're going to run a pod we're just going to call load generator, but it's just BusyBox. And what we're going to do is, let me see here, we're just basically going to run just keep wgetnet over and over and over again to draw some, create some traffic. Let's do that. So we watch here, we'll see these targets start to creep up, and then the pods start to deploy. Clear some space here. My MacBook is very unhappy about this right now, but it's probably doing okay because I only have one instance of a Chrome-based browser running and no Slack.
And because you made it say okay.
Right? It's okay. It's okay. I'm just talking to it gently. It's okay.
We're all on the edge of our seats here.
Right? This is so exciting. I found something more exciting than watching grass grow. Hey, there we go. So we're at 249% of CPU on that one, which is way over our target. So in just a moment here, the HPA is going to change and here we're up to 4 replicas. So it went from 1 to 4. So we can actually, let's stop this. That's enough. We look over here, we can see, hey, we found we got an event. We found the HPA, we found the secret, and this is the response. Here, I just have the response coming from, in this case, a Wavefront, but whatever your tool is, they'll say, hey, status, okay, this is, hey, we created a message. We created an event. So this is the event it created. So we can see new size is 4. Reason, this is right from the HPA message. And it will, the same thing of 5, and then we'll see it on the scale down too. So this tag here, I just tagged it with scale, as we saw in here, it just says tag scale. You probably have like a tag with an app name, so like our cool app. So that way, when you can look at the events, they would match up. For other things like Honeycomb, there's actually, you would put it towards the, you make a marker on the data set itself. So the specific data set you want, you would just create as like a scaling message and what it was. So then they would show up as markers on the chart. In Wavefront, you can use the events a couple different ways, but let's see, they start scaling back down yet? I don't think so. No, they're not scaled back down yet. Takes a minute, so it's back down 0%. So they'll start scaling down there. So if we actually look at sort of how this works, because it's running in Kubernetes, we can leverage the Kubernetes SDK and Go to do in cluster, which I'll show you in a second. But if we walk through sort of the steps, like I said here, we spun it here, we spun up the server and we started the receiver. So the receiver we're running is right here. So this is the function that gets called whenever the whenever a message is received, like I said, it marshals that in. So this is saying get the secret. It's running this this function over here. So if we go look at check HPA, so check HPA is getting the client, and you see here it's calling another function, Kate's client. So we go up to Kate's client here. It creates an in-cluster config. So first thing it does is to try to say is like, hey, am I running in a Kubernetes cluster? And then what it's doing is if there's an error, it'll check to see if there's a file called kubeconfig. So like if we could run this right here locally just using go run, but we'd have to supply a kubeconfig file so it knew how to talk to the cluster. So the first thing it tries is how are we in cluster? Can I do that? If not, give me a kubeconfig file. If we can't read the file, we're no good, or try and start it. So that just creates the client. So once it has that, it can use that client to make calls to the Kubernetes API. So here we're looking for the autoscaling v1. So here you can see like the different. So you can see like here's apps v1, daemon sets, all the different Kubernetes API components. So right here, this is very like HPA specific, but we could also modify to make it really general and say like, if an object shows up, if an event for an object shows up, go check the object and see if it's annotated or whatever you want to do. So you can see here, we're saying in this namespace, go get the HPA with the name that we're passing through. And it says, hey, if I didn't find it, or if it has any problems getting it, return that, or if it just totally blows up. So here it's found it. So it'll use the get annotations function on that object and return those. And then it'll check to see if this key exists. So it says get the annotations, does the HPA event key exist? Okay, then return that. Otherwise, return nothing. So the first thing it's looking for is it an HPA? So in this case, we checked here if it is horizontal pod autoscaler, and if it's yes, then check to see if it has a secret. So if the secret basically doesn't exist, we're just gonna ignore it. So we could create another HPA, or I could do something like switch windows here. I could do something like this one's called HPA patch. Oops. So it's this annotation right here. So we deleted it. Now any scaling events we get, it just won't bother sending because there's no because that annotation's missing. So what it's actually doing when it goes to send the message, it calls this send message here, which it's passing over where's the secret, which is that value is just that text. So it has just default /PHP. So it's not really passing the secret, it's passing the location of the secret. So once it does that here, we're going to call a function to go get that secret. So just very simply splits that string and says, this is the namespace, this is the name of the secret, go get that secret. Again, can you find it? Did you not find it? See, this one should say secret because I copied and pasted and never changed that. So then if it finds it, it returns the actual data from the secret. So if you're not familiar with what a Kubernetes secret looks like, actually I could just do no, it's PHP. So if we do, let's just do, let's output JSON through JQ. So this is what the secret actually looks like. And you'll see it's all base64 encoded. If you notice, there's a little trick they added. So when you go to create a secret, normally you'd have to create that secret with the base64 values. But if you see here, there's a string data where I can say, I'm going to give you a string, you're going to make a base64 when you put it in. That does not work the other way. So you can't say, like, give me the string data back. It's a one-way operation. It's, again, it's not like it's encrypted or anything. So see, there's that data.url. We send it to, hey, there's the URL. So
Thanks for your secrets.
So we're sending just the data. So we said just secret.data. So the only thing that's in secret.data is the URL headers body. And this is the format that, again, we have to put it into an object. So this struct has the headers, URL is a string, this is key value, and then raw JSON for the body. So,
Oh, yeah, right. And that raw JSON is the thing that lets you not define the struct for every single provider that you want to talk to.
Yeah, it's basically, you'll see here, it's basically, you can see a raw message, it's a byte, but it actually implements marshaller and unmarshaller, which if you just do a byte, that does not work. I found out the hard way. So if we're trying to send a message, right, we go get that secret, and then we're going to prep the message. So you can see we have message, timestamp, and the secret. We send over to prep message. So it takes that secret data. And then what it does is it is going to unmarshal the secret data into this format that we're going to send back. So give us the secret headers and put them into the headers maps there. And then this one's a little goofy, but what I want to do is I'm using, because again, it's bytes, that JSON raw message is bytes. So we're doing basically find and replace. So in the secret body, find the byte of message and replace it with the actual message we want that we're passing down. And then because it's not replacing it, we assign it to this B1. Then we do the same thing again. We say, now take B1, look for time, and if it's there, replace it with the timestamp, and then save that as the body. And then the URL is just the string, pass that string through. So then we return this data back. So that's the prep message. So then we have data there. And then if you've used the HTTP package in Go, your body has to be in an IO buffer. So we tell it to create a new buffer, a buffer of bytes. So we do that. So we're going to make a post request. We're going to post it to that URL, and there's the body. But now we need to add the headers. So we do this request header set. So in the data headers is a map. So we just say iterate through them and set each one of the headers in the request, and also we're setting the header content type. And then we tell the HTTP client to go do that request, close it up, grab the body, and then that's what we're printing to it. That response says, hey, what was the body? So this is the body of the response from the API. So that's what's coming from Wavefront. And that's basically it. So that's how it works. And then I'm putting in a Docker container. One thing I love to do with Go with Docker, since it's compiled, is I'll use a Go container image to build it, and then I'll put it in a Scratch container. Now the only thing you have to be careful about when you're using a Scratch container is if it's doing anything HTTPS where it needs certs, you have to put the certs in too. So this is where stuff breaks if you don't do this piece. But if you look at that, the actual size of that container image, let's see what we can do. Docker. So you can see here, it's 40 meg. So it's a nice small image by doing that.
So I hold an unpopular opinion that Scratch images are garbage and you're a horrible person for using one, because it effectively means I can't do any debugging inside that container.
I was just going to say the number one downside is other images I could do, like I could do a kubectl exec into a container. So we're in the wrong names. I guess we could do it. We're still in the same namespace. Watch this. So normally I'd say like, oh, IT, in this case, name, thing into HP sender. Oh, I have to do this, right?
Oh, you spelled exec
You have
wrong
a
as well.
T at the end of exec.
I'll get a little fancy. HP sender. Nope. There we go. Normally I do, hey, cool, let me bash in there. What? How about, nope. To Paul's point, so literally the only thing I could actually run would be, I guess I have to do, I don't even know where to put it. Where did I put it? No, I just put it. But yeah, so there's no sort of, so you can't, because there's already one running. So literally that's the downside of using Scratch containers is there's nothing in there. So if this thing wasn't working right, I can't ping, I can't even remote into it. That's the big downside.
Yeah, and that's okay when it's your image, but when you're distributing the image and other people need to try and figure out what's going on, it's not always easy for them to like grab your binary and stick it into a fatter image so they have debug tools.
Mm-hmm.
So I generally encourage folks to use Alpine or like Debian Slim or, you know, one of the other pretty small images where you're only adding an extra 30 or 40 meg to the image and you get at least, you know, bash and curl and ping and a couple of other really basic things.
I mean, if you look here, here's a Buster Slim Node image, and that's with Node and everything. I mean, in the grand scheme of things, what's 161 meg versus 40?
Right, as opposed to kindest Node, which is 1.3 gig.
Yeah. Yeah. I mean, there's people doing like a full blown, like trusty image just filled with stuff is, yes, right. is less good, but you can still do, even if it's, this piece is still, because like this Golang one, that one should be here. Because it would have built with it, so why isn't it here? Let's try building it quick and just see.
And good on you for using multi-stage builds.
Yeah. Oh, and you're using the fancy new Docker build as well. The what's it called? Or is that now the default?
I think this is the default.
Wow. Oh, it's all growed up.
Yeah.
I guess I need to upgrade my Docker.
Yeah, like I even like this for so yeah, this Golang image is decently big because it has all sorts of dev tools. Even if it's with where you'll have, like, say if you're doing Python and you have some modules that need to be compiled and you have a bunch of like dev requirements, is you can still then build that whole, either as a virtual environment or whatever, in one image, and then in a second stage just bring over the final built components.
Yeah. Yeah, I think pretty much now all my Docker images are multi-stage, and it just keeps things so much nicer and cleaner.
You can also do, you'll see here, I just have from 0 because I didn't name this one because then they're just numbered. I could also do as Golang builder and then say from Golang builder, do the thing.
Yeah, I've seen some that are like, have like 10 or more like source images where they're grabbing different binaries and stuff from. And it gets pretty interesting. And of course, then you get to the point where you can't debug like what binaries have come from where and all that sort of stuff. So there's definitely a line you can cross where it becomes less useful as you add more. But certainly 1 or 2 stages can be super, helpful.
Yeah, and I think also if it's all like, what are you gaining? Where it's like in this case, oh, we saved 100 meg, who cares? But if it's like you said, it's your own image and you're going to deploy 100,000 of them, okay,
Right.
now that adds up to something.
Right.
Whereas you're doing like a 20-stage build to save, 50 meg on a image that you're going to run 3 of them seems like a waste of time.
Right. So basically what we've got now is we get the event pushed to wherever, in this case, Wavefront, with basically, an autoscaler thing happens. So I would imagine the next step is then you overlay that on top of your graph that shows like response time, or your graph that shows error codes or something. And
yeah, whatever.
way,
so yeah, you'd want to, let's see here. Let's just pick one right here. I have mine here. This one is not doing it right now. Yes, thank you. Thank you. Yeah, so you want to add your events. Actually, we can just create a new one. It's a little slow today. Oh man, there's too many of these. Let's see. All right, and we want to, oops. No, it's not coming up yet. No, this is not the font. Oh, is that 12 here? Oops, no.
well, that's okay. We can pretend you did it.
Yeah.
But the idea is you would have like these, I guess, vertical lines through your graph, kind of showing you where things have happened, right?
Here. Yeah.
And that way, if your graphs suddenly go haywire, you can say, oh, well, that's because a particular event happened. That's because the autoscaler went down or up or whatever.
Yeah. I don't know why it's not doing that. Yeah, so it would be, hey, this is, it could be both on the resource side. So like, hey, why is my kube cluster free memory dropped dramatically or whatever? It's like, right. Oh, this HPA event kicked off and spun up 50 more of those or more. I think that's not that big of a deal to see normally, right? Because it's just the number of pods going up and down. But I think more commonly is, hey, I have an app that's running in Python or whatever, and it's running Kubernetes, and I have my Wavefront integration or New Relic or whatever, and I'm sending alerts and performance stuff and everything like that. It just has no concept of, oh, there's now 50 of me.
Right.
And why there's 50 of me. So you may want to see, here's where my thing scaled up and down. It was because of CPU. And then these messages, you would modify it however you want for that particular type of event. What levels, other tags you want. These are the details, but again, you put in whatever you wanted.
Yep.
But yeah, the idea is you can sort of spread that across other data sets that are not directly Kubernetes related. Because I think that's one of the challenges too, is if you look at,
oh yeah, I guess it could affect your like RDS database performance because suddenly you've got a bunch more clients connecting to it. Mm-hmm. And that's not something you would get exposed from like your metrics that are in Kubernetes to be able to you know,
Yeah,
look
all
at.
you'd see would be like client count going up, and
Right.
and that's it. And it's like, well, I don't know why. And I think that's from kind of what I've come to feel is what I always thought was like, oh, like we get a whole bunch of data somewhere, and then we can kind of like figure out how to look at it in a way that's useful. And I found that you just end up with so much data that you just
Yeah.
either ignore. And it's like, what do we want to know? How do we want to see it? And then how do we get that minimum amount of data? So like for some cases, you'd be like, oh, we have this, say Kubernetes plugin for this observability platform. Like, well, no, I don't want to just flood it with Kubernetes events and
Right.
pods and stuff. Like the key thing I need to know is when this app scales up or down, or how many pods it has. And instead of HPAs there, here we could have gone with deployments. So anytime a deployment changed and scaled up or down, why, whether it's an HPA or you have some external system that modifies deployments, or usually you would mark that using your CI system, be like, hey, we did a deploy, the version changed on your graphs, whatever. But you may want to also mark on the Kubernetes side, like here's where the actual rollout happened.
Right. And I think when deployments do a role, I think like a scale or a role or whatever, I think in their conditions, they say why. So you'd be able to sort of work your way back to the like auto scaler or manual like scale or whatever someone did. So is that maybe the next like step in this would be to make it more generic so it can sort of deal with any kind of object or events?
Yeah, I think that's where I want to, once I kind of got like a handle on the different pieces of getting the data out of Kubernetes and then getting it marshaled and off to another site, is changing this to, hey, instead of we're going to get these specific things, and we can even do more detailed configs of what the output messages look like, or other conditions where you can say like, hey, don't send on everyone, only when, filterings if you want. So say like, hey, I want auto scaling messages, but only on scale ups or whatever.
Yeah, and I think the Kubernetes client has a dynamic set. So if you don't know what it is you're going to get, you can set it to that. And it sort of, I guess, probably unmarshals it into an interface or something, or maybe it's smart enough to figure out what it is. And so that might help there. And I guess the other thing that might be useful or interesting is to look at maybe moving away from using annotations and actually like do a CID, so that people could be very, declarative in a kube manifest that would do it, rather than, and that way you wouldn't have to be constantly subscribing to random events.
Yeah, because that's basically, if you look at what's happening here, is just like subscribing to every event, and then if it's an autoscaler one, then it's getting the autoscaler every time and checking the configuration to see if there's a secret and all that stuff like that. Whereas, if that was in a CRD, which was, kube events or whatever, it could just grab that and deal with it as only watch for the events that it actually is looking for versus checking the annotation each time.
Yeah. Nice.
Yeah, so this, so go back here. This, in its currently working-ish state, is on GitHub. So if you like pulled down this repo and then just ran through this right here, ran through these instructions, basically you could replicate what I just did as far as scaling it up and scaling it down and generating it. The only thing you'd have to modify is in here is where you want for your example, where you want to send it. One of the things they changed, it's now Pipedream or something, but there's request bin and all those other types of sites where you can, even if you just want to see what it looks like. And you can even do that if you're interested to see what you can do it right now real quick. If you want to see what those cloud events actually look like, we can modify the sender. So instead of sending it here, we'll send it to this bin. Oh, this is annoying. Do I have to open another window? Let me see. Okay, now it's happy. So yeah, so you have we just grab this endpoint. Well, then we'll just change this here. So we're gonna set this trigger and just send the events there instead. So let's see, this is sender. So let's just apply this one again. Oops, what did it not?
Uh-oh.
Connection refused. Interesting. Wait, I'm in the right namespace, right? Let's see. Oh, there we go. I think it's just my Mac slowly melting down. So, cool. So now, if we go back here, we can also trigger some events. Let's do it. Generate some events. Actually, we should be able to. That should be an event. Right, there we go. Yeah. So this is what the cloud events look like. So they have the headers. You can see the source, subject, all that kind of fun stuff. And then you can see what the involved object is. So in this case, it's a pod, what the name is, what the message is. There's any other managed fields on it. So you can see, so this is what all the events look like. So let's do structure. This one, you see create container. So this is what we're subscribing to. We're getting every event. And then now we're just, filtering for the HPA ones. But if you want to see what cloud events look like, this is their format. And they're not Kubernetes specific. In this case, we're talking about, Kubernetes stuff, but in general, this is just the standard cloud event format.
Nice. Cool. Well, this was awesome. I think it's probably a good time to wrap up, unless you have anything else you wanted to quickly talk about.
No, unless something popped up in the chat or anything. That was about it.
Woo!
Nice.
Our first thing on Knative and eventing stuff. I like this. Knative stuff in general has been something I've been planning on looking into in my long list of all the things Tiffany needs to learn and know in the near future. So having this versus just reading through documentation is nice.
Yeah.
Yeah, I feel like a lot of the stuff was very much like how to basically try and copy AWS Lambda, but on Kubernetes. A lot of the like Knative stuff versus like what about some smaller use cases? Because I was looking for there's the Heptio team had made a tool to like send events from Kubernetes, and so that seemed like it had been abandoned. And I asked them, and they were like, "Yeah, but why wouldn't you just use Knative?" I was like, "Oh yeah,
Right.
good point."
I guess
Cool.
their tool should have a thing of go to Knative.
All right. Well, let's wrap this up. Any final words? Going once, going twice, and I guess I will hit the button that makes the show end.
See you all next week.
Bye.